All right, let's take a look at this problem. This is problem 4 from your homework. This is a lot like what we did today. And then if we looked at the next problem, is this the falcon flying or something like that? Yeah, an eagle is flying. It's a little bit different, but it's kind of the same. So let's set them both up. So this would be problem 4. This would be homework problem 4. So let's take a peek at this. All right. So homework problem 4, I got to go back to it. I'm sorry. I'm going to get my basic. We want to know how far it's going with a velocity in the x direction of 265.5 meters per second and a height is equal to 1.6 meters per second. We want to know what's its range. How far did it go? All right. So let's take a peek. Nothing too huge here. V naught in the x, so it's bare, and this is to an earthbound observer. This is how far it went to an earthbound observer. To an observer on the airplane, if this person is walking to an observer on the Earth, they're watching the person go by at 265.5 meters per second. But if I'm on the airplane next to that observer and he drops something, where does it fall? It falls right at his feet, because he's going at the same speed as the object in the x direction as the object that he dropped, and so they both hit. The object hits at his feet. But anyway, so the range to an earthbound observer is what we're after. Well, this isn't hard. Again, we just have to find out how long it's in the air. How long does it take to fall? Where V naught, again, we've got to go to our x component. We have our x component, we have our y component. We have to go to the y component because that's where the acceleration is negative 9.8 meters per second squared. So we've got that. And I need a time. So if the initial velocity in the y direction is equal to 0, the final velocity in the y direction, I don't know, but I don't care about its final velocity in the y direction. I'm just looking to see how far it went. I just need to know how long it's been in the air. Okay? So the time that it's in the air is equal to, okay, it's 1.6 meters per second. So 1.6 meters is equal to the initial velocity in the y direction times t minus 4.9 t squared. Well, this turns out to be pretty simple. But did you notice I paused there for a minute? I was like, well, how do we go about solving this? We already know the acceleration. I guess we could find the final velocity and then plug that in. But we can just do it this way, because it works out nice, because 1.6 m is equal to 0 t minus 4.9 t squared. Now it fell this far, so that's negative, because it's at 1.6 meters and it falls to 0. So its displacement is negative. Its change in y is equal to negative 1.6. So we take negative 1.6 divided by 4.9, and got to be careful. .32563 is equal to t squared. Now I take the square root of that. T is equal to 0.5714 seconds. I'm going to leave it as 4 sig figs. And so therefore, the range is equal to V naught x times that t that it took to fall times 265.5. Oh yeah, we should make it 4 sig figs. 151.7 meters. That's a long ways if you think about it. 151.7 meters. All right, out here on that, I think that's right. I'm not going to show you.